Problem 2. Summation n is equal to 0 to infinity of 3x to the nth over n to the 8th plus 1. Center again found easily is x equals 0. Not geometric, so we have to use the ratio test. The limit as n approaches infinity, we take the n plus 1 term and put it over the nth term, so that gives us 3x to the n plus 1 over n plus 1 to the 8th power plus 1 over 3x to the nth over n to the 8th plus 1. We have done this before where we flip the fractions upside down and we get the limit as n approaches infinity of n to the 8th plus 1, the quantity, times 3x to the n plus 1 over n plus 1 to the 8th power plus 1 times 3x to the nth. It's really a good idea to simplify this so we can find out what the solution is. Easy thing to do here is cross out those 3's. Then taking a look at x to the n plus 1 over x to the nth, you want to reduce that. If you think about it two different ways, x to the n plus 1 over x to the n, well, there's really one extra x up top. So you're just going to get x for a final answer. Or if you want to use algebra, you can say, well, when I'm dividing, I subtract exponents. So n plus 1 minus n would be x to the first. And now it's a little simpler looking. So we have the limit as n approaches infinity of n to the 8th plus 1 over the quantity of n plus 1 to the 8th plus 1 times x. Now we don't want to multiply out n plus 1 times itself 8 times and use L'Hopital's rule. Let's just use the process of saying n to the 8th on top, and on the bottom, when you would FOIL that out, you'd have n to the 8th on bottom. So that would simply give you a 1 because the other terms, n to the 7th, n to the 6th, etc., are really insignificant when finding that limit. So since the highest power is x to the 8th, and there's coefficients of 1 in front of the n to the 8th on top and the n to the 8th on the bottom, you get a solution of that limit being 1. So 1 times x is x. So at this point, we have the absolute value of x. Now, remembering what we're here for is to try and find when does this series converge. So what do we do next? Well, the ratio test tells us that inside that absolute value bar, as we get something less than 1, the series converges. So that means the absolute value of x must be less than 1. If, on the other hand, the absolute value of x is equal to 1, the ratio test fails and we don't know if it converges or not. And what we do know also is that the absolute value of x is greater than 1, the series diverges, and we don't want that. We're looking for the interval of convergence. So looking at a number line, if the absolute value of x is less than 1, we know it converges if we use fractions like -3/4, -1/2, 1/3, 4/5. We could certainly use 0. And so we start getting an idea as all the numbers in between -1 and 1. However, if the absolute value of x equals 1, we don't know a thing. So if we put a -1 in there for x, it certainly would equal 1, and we don't know because the ratio test fails. Likewise with x equals 1. This leads us into what we call an endpoint check. We need to check the endpoints of that interval, x equals -1 and x equals 1, to see if they converge or not. So again, at this point, we know that the power series, n is equal to 0 to infinity, of 3x to the nth over n to the 8th plus 1, converges between -1 and 1. So, but we need to check x equals 1 specifically. So we take that x, we erase it, and we have 3, 1 to the nth over n to the 8th plus 1, and that equals then 3 over n to the 8th plus 1 because 1 to the nth is just 1. And so at this point, we're back to a numerical series, n is equal to 0 to infinity of 3 over n to the 8th plus 1. Now we know that the ratio test fails. So what else can we do? Well, we've got lots of selections. So we want to think back to the previous sections and say, how can we prove if the summation n is equal to 0 to infinity of 3 over n to the 8th plus 1 converges or diverges? So if you were thinking the limit comparison test, you're right on. Summation n is equal to 0 to infinity of 3 over n to the 8th plus 1. We're going to compare it to the summation of 1 over n to the 8th, which is a p-series. So the power is 8, greater than 1. So this converges. Now that doesn't mean the new series converges, it means that 1 over n to the 8th converges. So we've got another step here. So we take the limit as n approaches infinity of our known p series 1 over n to the 8th over our unknown series 3 over n to the 8th plus 1. Doing the flip-flop of the fractions, we have limit as n approaches infinity of n to the 8th plus 1 over 3n to the 8th, which when we take that limit, we get 1/3. And certainly 0 is less than 1/3 is less than infinity, or 1/3 is positive infinite. So we find out that our unknown series, 3 over n to the 8th plus 1, converges. So now we know the power series, 3x to the nth over n to the 8th plus 1, converges at one endpoint, x equals 1, and between -1 and 1, the other endpoint. So how about x is equal to -1? So we take our 3x to the nth over n to the 8th plus 1. We change that x into a -1. We get the summation 3, -1 to the nth over n to the 8th plus 1, which is an alternating series. Recall that the alternating series is always smaller than the positive series. So since 3 over n to the 8th plus 1 converges, summation of the alternating series, 3 times -1 to the nth over n to the 8th plus 1, converges as well. And that's by the absolute convergence theorem. So finally, the power series, 3x to the n over n to the 8th plus 1, has a center at x equals 0. It converges over the interval from -1 to 1, including both endpoints, and your radius is 1 because you're moving one space to the left and one space to the right of the center to get convergence.